Hello and welcome to this new episode of my series where I check out quantum technology companies' websites from the space of quantum computing, quantum sensing, and quantum communication. In today's episode, we are looking at Infleqtion with Q. So here I'm at the website of Infleqtion.com. It says Infleqtion raises $100 million to scale atom-based quantum solutions for national security and next-generation intelligence systems, backed by new, existing, and strategic investors like Glynn Capital, Morgan Stanley, and so on. And then there are some smaller ones down here. So what I take from that is it's about atom-based computing solutions. It's national security. Okay. So probably something that has to do with either communication, like encrypted communication. But let's not guess. Let's go down and see what we have here. Experience quantum advantage, full spectrum quantum built on neutral atoms. So that sounds like a neutral atom type of quantum computer, maybe. It's a bit hard to read, to be honest, like with the background changing and that bright letters, it's a bit hard. But it says we are creating quantum technologies that redefine what's possible in precision sensing, secure communication, and quantum computing. So we have sensing, communication, and computing. So all quantum technologies. Let's see what else we have here. We believe that the power of quantum will expand human potential. Quantum is no longer theoretical. It's driving real-world breakthroughs today. We deliver cutting-edge sensing and computing solutions that accelerate progress in material science, artificial intelligence, energy, space, drug discovery, and national security. So these are all the applications and markets that they are targeting with those quantum technologies that they are offering. Here we have something about quantum computing to scale. The power of neutral atom quantum computing. We are layering the foundation of scalable fault-tolerant systems. Our advanced error correction platform featuring dual species atom arrays with low crosstalk measurements ensure fast, precise operation that drive long-term stability. With a roadmap to exceed 100 logical qubits by 2028, our world-class team is transforming quantum hardware and software into practical solutions for the most complex real-world business challenges. So again, we see a commitment to a roadmap, and I guess we will see more of that later, but it says 100 logical qubits by 2028. And we see that another interesting thing here is that they're talking about this dual species atom arrays. So that's probably also an interesting feature that we will learn about a little bit later. Then we have quantum sensing here. Quantum sensing, precision for critical infrastructure and security. Quantum sensing is transforming navigation, communication, and security with unmatched accuracy and resilience for defense networks to geospatial intelligence in GPS-denied environments, ensuring reliability where it matters most. With Ticker, with Q again, Spywire, and Exact, also with Q, to tackle real-world challenges in energy, space, and national security. So Ticker is this box. What do they mean by that? So quantum sensing is a technology that uses quantum properties to sense something, right? And what do we sense here? So it says something about navigation. So this could be like a compass, which you have in an aircraft, but it could also be like an accelerometer. So you could have a quantum-backed technology that measures acceleration. We already have accelerators in our smartphones, for example, but those are semiconductor elements in a way, or nanomechanical elements, and they can actually experience drift. So you might not be able to precisely measure the exact movement by using the accelerometer. I mean, in theory, if you knew the acceleration via physics, s equals 1/2 times a times t squared. So basically you can calculate the distance if you know the time and the acceleration. So in theory, if you had a very precise accelerometer, you could also map, let's say, the movement of something or somebody. So that could be something, but there could also be magnetic sensing involved here. So if you had a very, very fine resolution of magnetic sensing, you might also be able to use that in order to navigate. Then it says something about communication and security. So basically using those sensors also to build communication devices and to make something secure. GPS denied, which basically means that, for example, if you are below the water, below an iceberg in a submarine, for example, that could be a case where you cannot have an easy GPS access. There are also ways to create areas where you cannot have a very good GPS access. Of course, if you are in a building, that might also be one of those places. Sounds to me like this is about general navigation, but probably also a little bit into the direction of, if you're talking about GPS denied in specific, that might also have some let's say, security and defense applications here. Then we have these products, Ticker, Skywire, and Exact. So that we will learn about later, because now we go to the last section here, which is neutral atom quantum cores, our foundational technology. So basically, that's now the message that we need to know. So they use this neutral atom cores in order to build all of that. So quantum computers, quantum sensors, and also communication devices. Nature's perfect qubit, scalable for millions of qubits. So again, this is the statement about if you use an atom or an ion, it is the perfect qubit because it always behaves the same way. Every atom is built in the same way, which is not true, for example, for semiconductor systems, which are compositions of thousands or millions of atoms, and they always have to be tuned a little bit. So that's probably what this also refers to here. Then it says, harnessing the inherent stability and precision of neutral atoms, we are building a quantum future with unparalleled control for real-world solutions. And then there's some news here, how to get in touch. So technical algorithms, optimization and solution, partnership and sales, and careers. And then there's a newsletter which you can subscribe to down here. Let's scroll up again. So there's products, solutions, companies, and then you have careers, news, and contact. Let's take a look into the products real quick. So as we already saw, there is quantum computing, software, sensing, and cores. So now it's not computing, communication, and sensing, but now it's computing, software, sensing, and cores. So let's first look at the computing part. So we see here in the background some optical devices which are being needed to create those neutral atom computers, or to manipulate them and control them, also to cool stuff. So it says, again, it's a bit hard to read with this varying background. Scale with Q again, the most scalable path for commercial quantum computing. Neutral atoms are outpacing industry innovation today. Then it says something about neutral atom computing technology, which is using those arrays, high fidelity gate operations, laying the foundation for scalable error correction and reliable quantum applications. Gate fidelities with up to 99, with larger than 99.7 entangling gate fidelity, error correction architecture. Here it says something about the software, so integrated software platform. So probably they are also working on their own software here. It says enhances and increases performance of quantum hardware by 10x. So their software is probably also making the systems perform better. So there might be some error mitigation or something, or like specific pulse controls which are designed for this computing system, which this software is adding. Maybe just the software stack itself is written in a very performant way. Here's something about performance and benchmarking advantage. Again, related to these 2D arrays. Here we can see one of those. So you have this array of the neutral atoms, you have these reservoirs, and then you have here basically what the controls are looking like, the different laser levels. So here you have the qubit with 0 and 1, you have the different transitions like optical transitions, readout, and so on. I think I should do a separate video on how this works in particular. But yeah, that's basically the different levels of control all the way from the qubit to the laser transitions. Then you have high performance quantum processing units. So this is the whole unit, what it looks like. So you have like the vacuum chamber, which probably has the atoms in it. Here in the center, you have a lot of optical equipment around it, like the laser sources, the whole mirrors and lenses and everything. So this is all sitting on a big optical table. And then, yeah, there's some breakthrough in qubit readout, faster, more reliable error correction. So this is about how these qubits are actually being analyzed, and the error correction scheme, next generation error correction with Rydberg connectivity. So that's also some technical advantages here. It says Infleqtion's quantum processors leverage long-range and non-planar connectivity to implement quantum low-density parity check codes, significantly improving error correction efficiency and speed over traditional surface codes used in superconducting qubits. By optimizing Rydberg interactions across multiple energy levels, n equals 50, 83, and 90, this approach unlocks more scalable and robust quantum error correction. So this is about a new type of error correction that they can implement here. And it says long distance because it doesn't only connect neighboring atoms or neighboring qubits, but it can go, as you can see here, indicated by these arrow over longer distances between sites that are away multiple atoms or from each other, or multiple cells, unit cells from each other. Okay, then quickly go on the software side. So it says something about the software making quantum practical. There's Substack, of course, also with Q, because we are in a quantum world here. It explains the different layers. So you see hardware, which is what we just saw before, the optical table, you remember, with the lasers and all the optical equipment. Then you have control on top of that. This is like what is probably turning on the lasers, like controlling literally the physical instruments. Then you have the compiler. The compiler is what translates the algorithm into the control. So it actually knows what the machine physically can do, like as in you can, I don't know, connect this and this atom, but not this and this one. So then you have to kind of make sure that the algorithm that you're building is mapping onto what is actually possible with the systems in terms of operations. So it will compile an algorithm into a sequence of commands that have to be done, that are like practically done on the machine. Then you have the algorithm level. This is what we already know, like you have these different gates, the universal gates on the quantum computer, and on top of that you have, of course, the application that this algorithm is going to serve, like the logistics application, the security application, whatever, right? And it looks like, from what I see here, Substack is basically putting all of this together into one stack, which is also part of the offering of Infleqtion. Here it says something about Substack compared to other systems, so other cases. So here you see Substack, Qiskit, and the ideal case. Probably this is a measurement of some shots. Let's see what it says here. Substack enables you to write quantum programs in any source language and target any quantum computer without any quantum experience. Use Cirq, OpenQASM, and Qiskit, or build your own with an open API. On standard benchmarks, Substack enables 10 times performance gains. Okay. And then we see here shots, which is probably repeating a specific type of algorithm. And then we see here like the number of counts on a specific state here. Okay. So with that, we move on to the next. Oh, now it looks different. Let me do this again. Also, the page looked a little bit different. So now we move here. I think it was also a different URL. So this is infleqtion.com and this is info.infleqtion.com. Okay. So we move to quantum sensing, precision for critical infrastructure and national security. So here we see quantum sensing is reshaping how we navigate, communicate, and structure global and secure global infrastructure. So these are the applications that are being targeted. We see here this GPS, ultra stable timing. So this is about using probably the system as a clock. It also says that here, atomic frequency clock. So measuring time more precise, which is also important if you want to do navigation. Of course, you need also, as I told you before, you need to know, for example, the acceleration, but you also need the time, right? Okay, and then it says Ticker provides ultra stable long holdover timing, securing networks, data centers, and national security infrastructure against GPS vulnerabilities. Designed for resilient, high-precision synchronization, Ticker ensures operational continuity in contested environments. So, okay, that's very much like targeted towards big organizations, like, for example, national security, that want to have their own clocks which are working in a very stable way to allow for very precise time measurements for these specific applications. So security, energy grids, because energy grids, they also need this, because if you look at an energy grid, you're basically moving energy, right? And in form of electromagnetic waves. So basically at the speed of light. And that means you have a real-time optimization, or not even optimization, a real-time logistics problem, because the energy is produced somewhere and being consumed somewhere else, and you have to be able to kind of synchronize all of these producing sources and the users of this electricity and match all of this together. And for this, you need to be able to communicate through all of these different sources and consumers. And that means in order to make a good communication, you also need some type of clock. This is like a communication question. Okay, and then what else do we see here? We have the quantum RF receiver, and we have exact inertial sensing. Exact is a quantum gravimeter, so that's again on the acceleration side of things. Solution delivering high-resolution gravitational sensing for navigation, exploration, and security applications. So basically, it measures the gravitation and creates thereby you can create thereby like a map, because the Earth's gravitation very much depends on the local environment that you are in, right? Like we always say it's 9.8 or something, but of course, if you could measure much more precisely, you would measure basically all of the environment and the effect of gravitation around you, because everything attracts everything, right? Like mass attracts mass. And then if you could sense that very precisely, you could basically create like a gravitation map of the planet, and that you could also use for navigation in, for example, these GPS denied environments. Okay. And here it also says high precision gravity mapping for national security and geo-exploration. Of course, that could also be used to, I don't know, find oil sources, rare earths, whatever. There might be ways to use that for this as well. I don't know. I'm not an expert in this. And then there's quantum navigation takes off, and I guess that goes into a similar direction. It's about the GPS and then about quantum sensors as well. In the sake of time, let us quickly go to the last one, which is quantum cores. We see again the fundamental technology here. So you see these UHV science cells. So UHV, I guess, is for ultra high vacuum. It's a glass cell. So that's important because you want to have optical access to your atoms, right? So you need some place where you can create an ultra high vacuum to separate these atoms from the atmosphere around. You cannot just put them in air, right? Because air also has a lot of atoms which would crash into your quantum system, and then you couldn't control it that nice anymore. And you also need optical access because you want to have lasers which you can shoot on those atom arrays to control them and to manipulate them. That's why you need these UHV glass cells. They are very important core technology here. And we also see there is another thing to look into. It's the cold atom source cells. So basically where the cold atoms come from, the CASC is the core of high flux atom delivery system. Differential pumping of the system is maintained by an aperture in a silicon plate that isolates the user's vacuum system from the higher pressures required for high density 2D MOT operation. So this is like how you create those atoms that you later on use for the applications. And then what else do we see here? We see magneto-optical trap systems. So this is how you confine the electrons in that space so that they get into this array shape that we saw before with each single atom at a specific position. You can use that as magneto-optical traps, MOT, or Bose-Einstein condensates. This is also something for another video maybe. And we see some more core technologies here, the double mod and the Rubecki, and some more physics platforms, coil assembly. So here you see the whole stack of technology that is being used and employed in those systems. Ion traps, so they basically create everything which they need for their systems here also as or have it here as single components. Okay, now let's quickly take a look into the solutions. So we see life sciences and drug discovery, which is apparently a 9 billion biopharma bottleneck. There's material science here, which is also, of course, very interesting for quantum computing, because materials basically work by quantum mechanics, and if you had a quantum computer you could simulate them better. Then we have space and frontier. So quantum innovation takes flight, revolutionizing navigation, timing, and exploration in space. That's what we saw before with those sensors. And then we have the national security and resilience, which is about communication basically and sensing. And then we have energy and resource exploration. That's what I said before. You can use like the gravitational properties probably to also say something about the resources below you. Then we have something on the company, our mission. So our mission is to commercialize atom-based quantum products that provide orders of magnitude improvement in sensing and computing applications. Founded on Nobel Prize-winning technologies, Infleqtion is the largest full-spectrum commercial quantum technology company in the world. And then we see a video here of what the company looks like. Company values. There are some values here: excellence, innovation, results, take risks, and urgency. We have the teams, the different teams here: board of directors, technical leadership, and business leadership teams. And with that, I think we are almost getting to the end. So there's some news here and a contact form. And yeah, I think also in the sense of time, let's call it today's video. As always, if you liked it, please make sure to subscribe to the channel to not miss out on any further videos. And there will be a lot of new videos coming up soon as well. And always make sure to stay hydrated so that you're ready for the next video. See you then. Bye bye.